Hello everyone. Today we're going to discuss another topic that is called colloidal solutions. So what are colloids or colloidal solution? Let us see the definition. A colloid or a colloidal solution is a mixture that is actually heterogeneous but appears to be homogeneous as the particles are uniformly spread throughout the solution. For example, milk, shaving cream, cheese, etc. So, it is a kind of a mixture. So, it is a type of a mixture. And what kind of mixture it is? It is actually a heterogeneous mixture. But it behaves similar to that of a homogeneous mixture. Means the nature is that of a homogeneous mixture. From outer appearance, it would seem just like a homogeneous mixture. But in fact, if we see the chemical composition, then it is actually heterogeneous. Now, why it looks like homogeneous? Because the particles are uniformly spread throughout the solution. There is no separation at the particle level. There is no separation of the solute and the solvent particles. So it seems that it is a homogeneous mixture, but actually it is a heterogeneous mixture. For example, milk. If you see milk, can you identify that it is a heterogeneous mixture? No. But in fact, it is a heterogeneous mixture. How it is a heterogeneous mixture? Because it consists of, say, if we mix milk and water, can you separate out milk and water just by looking at it? No, we can't separate it. We can't even distinguish that water is mixed with the milk. Only by some processes we can separate out that milk and the water. But other than that, it is completely a homogeneous mixture from outer appearance. But in fact, it is a heterogeneous mixture of milk and water. Next is shaving cream. Now this is commonly used. Not only shaving cream, here I have given an example of shaving cream, but all kinds of cream. Say cream from the milk, or say the other kinds of creams, say your beauty creams or toothpaste or any other kinds of cream. They are actually heterogeneous mixture by chemical composition, but it looks like a homogeneous mixture. We can think about it as a mixture that is made up of only one kind of constituent particles. Clear? Next is cheese. Now this is commonly used. It is a milk product, cheese. Paneer is also, which is known as cottage cheese, is also an example of a cheese. So this cheese is also a colloid because it is in fact a heterogeneous mixture, but it seems like a homogeneous mixture. It is made up of only one kind of constituent particles. We can not distinguish it based on its actual chemical composition. Clear? So we will see that in our upcoming slides. So I hope this is clear to you what is a colloid. Now next, colloidal solutions are also called colloidal salts. So sometimes these colloidal solutions are also sometimes, in short, they are called colloidal salts. Clear? Now let's move on. Some properties of colloids. Now we have learned about the different properties of a solution, properties of a mixture, properties of a suspension. So let us see the properties of a colloid. Now these properties of a colloid will help us to understand why it is a homogeneous looking mixture, but in fact it is a heterogeneous mixture. So let us see the properties. Some of the important properties of a colloid are as follows. So the first property is it is a heterogeneous mixture. So don't get confused. It looks like homogeneous, but it isn't a homogeneous mixture. In fact, it is a heterogeneous mixture. Clear? Next is the size of particles of a colloid is too small to be individually seen by naked eye. Here, this is the property that makes it looks like it is homogeneous. The size of the particles are small. If we see through a naked eye, we cannot distinguish it. Other heterogeneous mixtures we can easily distinguish by our naked eyes. That yes, a mixture of sand and water, say suppose, we can easily distinguish it. Also there is a layer of separation, but here there is no such kind of phenomenon going on. As a result, our eyes seem that it is a homogeneous mixture. But the colloid particles are not that small also. They are big enough to scatter a beam of light through it and make its path visible. Now this phenomenon you will not see in a true solution. We'll come to that point. So here what you can say is that the colloid particles or the colloidal particles are small, no doubt. They can't be seen through the naked eye, but they are not that small also that they don't scatter the beam of light. They scatter the beam of light, and as a result the path is visible. So next point, it will be more clear. The colloids are quite stable. Particles do not settle down when a colloid is left undisturbed. Yes. Now here the main confusion comes. Generally what happens? A heterogeneous mixture, if we let it settle, if we kept it undisturbed for some time, we can easily separate its components, the solute and the solvent. But here colloids are just the opposite. They are very much stable. Normally a heterogeneous mixture is not stable, but this is a unique case wherein even if it is a heterogeneous mixture, but they are quite stable. Clear? Now this is another property, that particles of a colloid can pass through filter paper. However, we can separate them by a special technique called centrifugation. So if we allow it to pass through a filter paper, the colloids can pass through it. Therefore, colloids cannot be separated through filtration. Now this is also another property which is similar to that of a true solution. If you remember it carefully, if we make a true solution, it will pass through a filter paper. So here also a property has been shown of that of a true solution, that it can pass through filter paper, but we can separate it through another technique that is called centrifugation. So centrifugation is one of the techniques through which you can separate the milk and the cream. Normally the cream, which is a milk product, is also has milk in it. Not only cream, it has also some portion of milk in it, but we cannot separate it through any other method except this centrifugation method. Clear? Now let us move on to some common examples of colloids. Now in a colloidal solution, there are mainly two components. One is called the dispersed phase and another is called the dispersion medium. So what are these? Let us see. The solute-like component or the dispersed particles in a colloidal form is the dispersed phase. Means the components which is more like a solute that is dissolved in that colloid is called the dispersed phase, and the component in which these solute-like components or solute-like particles are dispersed or suspended is known as the dispersion medium. Now it will be better understood with the help of this table. If you see this table, if the dispersed phase is liquid and the dispersing medium is gas, and that type of a colloid is called aerosol. For example, fog, clouds, mist. Okay. Next one is, if the dispersed phase is solid and the dispersing medium is gas, that is also called aerosol. For example, smoke, automobile, exhaust. Now next, if the dispersed phase is gas and the dispersing medium is liquid, then that type of colloid is called foam. For example, shaving cream. Clear? Then there is something called, if the dispersed phase is liquid and the dispersing medium is also liquid, it is called emulsion. For example, milk face cream. Now this emulsion, one best example is the paints. In the paint, it is also a colloid, but it is made up of some chemicals. By the dispersed phase, that chemical is also a liquid in the liquid phase, and in which it is mixed, that is also a liquid form. So that type of colloid is called an emulsion. For example, milk. Say for example, milk itself is a liquid, and if we mix it with water, which is also in the liquid form only, here the water will be the dispersing medium and milk will be the dispersed phase, and that is also in the liquid form. So as a result, that type of an emulsion, that type of a colloid will call as an emulsion. So similarly, there are other dispersed phase and dispersing medium, and accordingly the name also changes, and there are different examples that are given here. For example, the cheese which you have taken, that comes under the type gel. You don't know what is gel? Yes, jelly like substance, or you can take jelly also, which is a very good example of a gel. So here the dispersed phase is liquid and the dispersing medium is solid. So you cannot consider the jelly to under the liquid state or the solid state. You have to consider it as a mixture of it. So it is called gel. Clear? Now moving on to our last slide, that is called Tyndall Effect. Now this Tyndall Effect is one of the important phenomenon that occurs in the case of colloids. Now this is named after the scientist who discovered it, Tyndall. So let us see what is actually Tyndall Effect. The scattering of light by colloidal particles is known as Tyndall Effect. As we have seen in the properties, that the colloids, they scatter the ray of light or the beam of light by its particles, and that effect is called Tyndall Effect. Now, in a true solution, the solid particles are so small that they cannot scatter light falling on them. This is the point that I was saying in that properties slide, that if it is a true solution, here we come to know that it is not a homogeneous mixture. It is in fact a heterogeneous mixture. Why? Because if it is a homogeneous mixture like the true solution, then it would have not scattered the beam of light falling on it. But in a colloidal solution, the particles are big enough, and as a result they scatter light. Now here it contradicts the homogeneity of the mixture. Here we come to know that a colloidal solution is in fact a heterogeneous mixture. It is not a homogeneous mixture. There might be some properties which shows that it is a homogeneous mixture, but in fact it is not. If we do this experiment of passing a beam of light through a colloidal solution, then it totally contradicts the fact that it is a homogeneous mixture. It is in fact a heterogeneous mixture. So you can see here, this is one example. Now in this example, we have focused a beam of light by our flashlight. So there is a solution and there is a mixture of water and milk. Now what kind of solution is this? It is given directly in your textbooks. Say it is a solution of what is called water, and there is a kind of salt which is bluish in color. Can you remember it? Yes, the solution of copper sulfate and water. So if you mix copper sulfate and water, it becomes a true solution, and this true solution, it will not show any Tyndall effect, as given in the above point, that if it is a true solution, it will not scatter the beam of light. But in fact, a mixture of water and milk, it will scatter a beam of light. It will scatter the beam of light. As a result, it will show the Tyndall effect. Similarly, some natural Tyndall effects can be seen in the forest. when a dense canopy of forest, where the light passes through when the sunlight passes through a dense canopy of forest, then the light gets scattered. So there you can see the Tyndall effect. One nice example is when the sun rises, and say if there is a small tiny hole in your window, and through that hole sunlight is coming, then that also scatters the beam of light. So that phenomenon is also can be considered as a Tyndall effect. Also, during the mist, there are tiny droplets in the air. Mist is nothing but there are tiny droplets in the air, and they also can scatter the beam of light. Or say the smoke, when there is a smoke in the air, they also scatter the beam of light. Clear? So these are some of the examples where Tyndall effect can be seen, and this is only possible because in all these cases the substances which scattered the beam of light is nothing but they are colloids. So if there is a scattering of beam of light, or you can say if there is it shows the Tyndall effect, then we are pretty much sure that it is a colloid. Clear? So I hope you all have understood today's video. So that's it then in this video. Thank you and have a nice day.